Good afternoon to everybody. Okay, we will speak about Envision protocol and his connection with an LCA, and the way in which a sustainability rating system can support an LCA, but on the other side, how an LCA can be used to evaluate the sustainability of an infrastructure. So, just to introduce the Envision protocol. Envision is a rating system, a voluntary rating system scheme that was developed by ISI, that is the Institute for Sustainable Infrastructure in Washington, that developed this scheme thanks also to the connection with the JOFNAS program of Harvard University. So there is a no-profit association that is ISI, founded by Council of Civil Engineers, American Public Works Association, and American Society of Civil Engineers, but also with Harvard University. Which is the importance of this protocol? This protocol is important because it's the only scheme that can evaluate all types of infrastructures and all sizes of infrastructure from the sustainability point of view, from the point of view related to the economic, environmental, and social aspects. So Envision can be used as a framework during design, construction, and operational maintenance phase, and can be applied for all type and size of infrastructure. I listed energy, water, waste, transport, landscape, and information. And the importance of this scheme is that these three associations listed in these slides understood the need to create a framework, a standardized framework that can be used for evaluating the sustainability of all types of infrastructures. In 2014, thanks to an agreement with ISI, ICMQ launched Envision in Italy and in Europe. So we are the same in the ISI in Italy and in Europe. So we can certify the project in Italy, and also we can qualify the professional of the Envision. Envision is a rating system, so it's structured with some different credits that represent specific sustainability indicators related to the environmental, social, or economic future. So Envision encloses all the three elements of the triple bottom line: people, planet, and profit. All these indicators are grouped into 5 categories that represent the macro areas of impact, according to which it's possible to evaluate the sustainability of a project. But because it's a rating system, there is also a score. So each credit have specific levels of achievement, 5 levels of achievement, that can measure the sustainability and the degree of the sustainability that a specific project can achieve. So these levels of achievement represent the sustainability that is divided into 5 steps, that growth. This slide shows which are the credits of the Envision divided into 5 categories. We have quality of life, leadership, resource allocation, natural world, and climate and resilience. These categories are very important because these represent the fact that every infrastructure project has an important impact on all these 5 categories, so on all the 3 bottom line aspects. The structure of the Envision protocol is very clear and linear. Each credit is structured in the same way. So we have the first one point that is the title and the identification number of the credit. Then we have the total possible score, the intent, so the purpose which the credit was want to achieve, and the metric that represent the way in which each credit will be measured. And then the most important is the levels of achievement tables that represent the different step of the sustainability. Envision listed 5 types of levels of achievement that you can see in the slides: improved, enhanced, it's very small, but okay, improved, enhanced, superior, conserving, and restorative. So the bar of the sustainability growth from improved to restorative. To evaluate the sustainability aspect, it's very important to produce the documentation. So to prove each levels of achievement, the project team, the owner, have to be compliant with the different specific requirements that each credit asks. And then there are also a related credits table that means the connection between a specific aspect of sustainability that credit want to pursue with the other to underline the merge of this element. In the Envision protocol system, there are 2 other tools. The first one is the certification process. So it's a voluntary scheme, but if an owner or a project team want to pursue the certification, can choose one of these 2 different pathways. So we have the project certification process that is divided into different and alternative pathways. The first one is pathway A, design plus post-construction, in which the verification and the certification of the project was obtained at the end of the design phase. So it's the design phase of the project that obtained the certification. But it's very important that at the end of the construction phase, there is a follow-up verification that can confirm the outcome of the project of the design phase. The alternative path is pathway B, post-construction, for which the verification and the certification was obtained directly at the end of the construction phase. The certification project is a third-party independent certification. So there is ISI in US, ICMQ in Italy and in Europe that is an independent evaluation that can confirm and gain the certification to a project. There are 4 possible levels to certification that we can see listed in these slides: verified from 20 to 29%, silver 30-39%, gold 40-49%, and platinum more than 50%. Another important aspect in the Envision protocol is the professional. So it's very important for sustainability that there is a specific qualified person that knows all the elements of the Envision protocol that can be applied the sustainability into a project, and then, if the owner wants, can brought the project to certification. These figures, he is the Envision sustainability professional. That he is a professional that after a training and an exam become a specialist, an Envision protocol specialist. This figure is also important because it is a really connection and an operational interface between the verifiers, so the third-part entity, and the project team, the owners, and is mandatory during the certification process. So it's a very important figure to spread the concept of the sustainability and the way in which the sustainability, thanks to Envision rating system, can be applied to our infrastructure project. This slide can show which is the situation worldwide. As you can see, we have, if I remember well, 145 certifications worldwide. There are also many other projects that are registered or under evaluation. And Italy, as you can see, is a very important part of this certification. In fact, ICMQ certified 7 projects, the last one last month. And as you can see, any type of infrastructure in Italy was certified. So we have 2 sections of the same wall itinerary Naples to Bari, from RFI that manage all the railway infrastructure in Italy, and Italfer that is the design firm of the RFI. But also we certified 2 wind parks in the center of Italy by S.p.a. Energie Speciali, now Edison Rinnovabili. So also project in energy field. But also we have a project that was mentioned before by Tecne, Stefano Susani knows very well, progetto del Passante di Bologna, that was certified last year. And then 2 other different projects. The first one is a plant in Cervia, that is a plant that can clean whole portal coast. And then the last one is Biopiattaforma, that is a project in Milan. That is a plant that wants to requalify all the waste into energy with some elements of, for example, net zero carbon emissions, etc. We have also many other projects under evaluation that you can see in the slides. More are related to the railway infrastructure. We have 4 projects related to railway station, but also another highway project, and the first project in Europe by Enel Green Power that is a cluster Brovales that are a photovoltaic park in Spain. So, which is the connection between Envision and an LCA evaluation? Envision included into his rating system different credits that require a specific intent. In most credit of the Envision, LCA is very important. It's a very important tool to obtain the intent of the credit, or on the other hand, an element that can help the project to achieve specific levels of achievement. So we can find different connections. The first one can be a direct connection, for example, with a credit for climate and resilience categories. That is the first one that names CR 1.1, reduce net embodied carbon, for which the connection is direct because the implementation of an LCA is required to obtain the purpose of the intent of the credit. But we have also some indirect connection. For example, with for climate resilience, CR 1.2 reduce greenhouse gas emissions, but also with an economic aspect evaluation that is included into LD 3.3, conduct a life cycle economic evaluation. An LCA can be used also to allow the intent of the credit. But at last we have also another connection that can be crossed. For example, with these 4 credits listed into resource allocation categories, for which the data that this credit requires can merge, can flow into an LCA, or on the other side, the LCA can be used as a tool to evaluate all these aspects. We speak about green public procurement or other elements. So if we have some specific data that are included into an LCA, we can produce a tool that explains really if specific aspect, for example, for green public procurement, can be evaluated for an infrastructure, or also the way in which a specific aspect can merge into an LCA and can allow to obtain a specific levels of achievement. This evaluation it's not very common for a design team. Envision require very specific aspect to build an NCA evaluation. So the LCA approach was not used for all the projects. In Italy, was implemented into 4 projects, more or less. to achieve a specific credit. For example, CR 1.1 or 1.2 or other credits that are related to the version 2 of the protocol. So it's a very useful tool that can help the design team or the owners to better understand the way in which an infrastructure can be sustainable. Now my colleague Michele will be in depth on the credits. Thank you.
So, good afternoon to everybody, and thank you, Silvia. In this second part of the presentation, I'll discuss about the LCA in the specific credits that Silvia cited. So the first is CR 1.1, that is a reduce net embodied carbon, and is a climate resilience section of Envision. And in this credit, the goal is to reduce the impacts of material over the project life, and the metric is the percentage of reduction compared to a baseline. So here we introduce the concept of double check, a double evaluation, the evaluation of the main project that is under assessment and the evaluation of a baseline. So the need to have a comparison between a common situation and the situation that is gaining in the project. From the point of view of calculation, the goal is to calculate, to analyze the embodied carbon of material that are used in the project. And in this sense, we have to consider the production process, so the raw material extraction, collection, management, transformation, to have materials and semi-finished products, components that are inserted in the infrastructure. We have also to consider the transport of materials, components from the production site to the construction site. And we have to consider the materials that are needed in the phase of replacement, repair, maintenance over the life of the infrastructure. We have many strategies to reach the goal of reducing the net embodied carbon in the infrastructure. Obviously, to use less materials, so to get the same goal in the service in the infrastructure, but with using less materials, or to improve material efficiency and durability. So if we are able to improve the durability, the service life of a specific material, we can reduce the number of replacements, and so we can reduce the amount of embodied carbon in this specific material. The last strategy can be use materials with lower embodied carbon. So in this sense, we need a comparison between materials within components, and not all in the infrastructure. So in this credit, we don't have an explicit reference to LCA. So life cycle assessment is not mandatory in the credit, but all the elements and all the activity that we have to do to prepare to demonstrate the goal of the credit are strictly linked to LCA. Even though we don't have a specific standard or specific tools to adopt in this credit, we have to demonstrate the data consistency and the methodology consistency. And if we are able to implement an LCA and we are able to demonstrate it, to adopt a strong view to collect data, and we are able also to be compliant with the data consistency in the verification process. The second credit is CR 1.2, that is about reduced greenhouse gas emissions during the operational stage of the infrastructure. So here we have an indirect connection with the LCA. The goal is to reduce GHG, and the metric is the percentage of reduction. So also in this case, we have to compare the strategy, the situation in our project, and the situation in a baseline. According to greenhouse gas emission, we have to calculate, to analyze the emission due to many many activities. So the production of energy outside of the system boundaries, the stationary fuel combustion, transport, waste and wastewater management, industrial process that are specific for the management of the infrastructure, and fugitive emissions. Also in this case, we have different strategies to implement for reaching the goal. The first one is obviously to reduce the energy consumption, the overall energy consumption during operation of the infrastructure. The second point is to reduce the specific GHG emission of the energy sources, so to move from non-renewable to renewable sources. In this case, we don't have an explicit reference to life cycle assessment or for the methodology. We don't have standards to follow or specific tool to apply. But also in this case, we need to demonstrate data consistency and methodology consistency in the comparison between our project and the baseline. So in these first two cases, we have a full life cycle assessment of the infrastructure, because the credit CR 1.1 is the analysis of materials carbon content, and the credit CR 1.2 is the analysis of energy carbon content during operational stage. So if we merge the goal of these two, the intent of these two credits, we have a full life cycle assessment of the infrastructure. Another credit, important credit, is LD 3.3. In this case, we have an indirect LCA evaluation connection, and we have to identify the full economic implication of the project. The metric is to determine the net impacts of the project, and the calculation system asks to apply a life cycle cost analysis. So life cycle is the economic tool of life cycle assessment. Life cycle assessment is the tool for environmental analysis, and the life cycle cost analysis is the twins of LCA applied in the economic files. So we have to consider all the cost of the infrastructure, project or investment, so that's the capital cost, replacement cost, annual or recurring operation and maintenance cost, residual value, but also we have to try to give an economic value also to environmental and social benefits and cost. So to translate in economic way, in economic evaluation, the environmental and the social aspects. Strategies can be to improving resources and asset management for sustainability, so to have a better management in the available resources, to balance the upfront capital cost with and long-term operational cost, and to add monetary values of social and environmental benefits. So in this case, we have an explicit request for the methodology to be applied, so we have to consider life cycle cost analysis. We don't have standard or specific tool, but we have always to consider the data consistency. Then we have other criteria where the connection of LCAs is not so direct, But it's important to say that many of these aspects are considered in a LCA inventory. So if we prepare a full life cycle assessment of the infrastructure, for example, to cover the CR 1.1 and CR 1.2, we have also many information that can be adopted to verify also the credit about RA. So the use of reserves in terms of recycled materials, the reduction of construction waste or construction energy consumption. So one important point is the baseline definition. So in CR 1.1 and CR 1.2, we have to compare our project with a baseline. So what is baseline? Baseline is a similar project and in which we consider the existing conditions or a strong alternative project to get the same results, to get the same function, and the standard practice codes on regulatory requirements, and we can consider also a similar project in a similar geographical area. So it is important to define also the baseline and to analyze the baseline with the same methodology and the same system bandages that we adopt to analyze our project. Another important point is about the construction site, because when we analyze infrastructure, the key points are to have a wide extension of the construction area in the majority of the cases, to have a large amount of material that have to be transported, and sometimes we have a very long supply distance. Sometimes we have to adopt specific vehicles, special vehicles for transport, and in many cases we are not able to adopt renewable resources to manage the transport system. And the key point is that the available data are only available during the design phase. Usually we are able to collect this kind of data during the construction phase, but sometimes we need to perform the LCA before. We need to perform the LCA during the design phase. In particular, if we want to compare different design alternatives. So one of the key points is to collect, to prepare to specific information and validate the information according to the construction site impacts. So to conclude a life cycle assessment of infrastructure, before the goal of certification can have the goal to evaluate the alternative solution and to choose the best option to carry on. So comparing both the environmental aspects and the economic and socio-economic aspects. Thank you.